Welcome, excuse me, welcome to the CEBA series of videos on data and on using data and on dealing with data. This is the first video in a series on creating data sets. And here we go into the background of creating data sets. We ask questions about data sets, and we look at why we link data sets to other publications. So this is the first video in this series on creating data sets, and my name is Leslie Mostert, and I'm, among other things, CEBA's data curator. And here we're going to deal with the background to creating data sets, and there are 4 other videos which you can watch to help you actually complete the task. So let's get to the deep background, if you like, in the principles of why do we have data sets that are linked to our publications of other sorts. Why has it become mainstream? Well, the first thing is that, of course, it's good science. When we put our data out there and make it available for people, we show that we're confident, that our data is good. It demonstrates to other people that we did what we said we did, because all the information is there. It means other people can check what we did by redoing an experiment. It means that other people can collect the data and reuse it, both confidently, but also with all the information that one needs to give going along with the data that you use. But it's not just good science, it's good citizenship. It saves money because people don't have to keep on doing the same thing again. And it's also good citizenship because it makes science less exclusive. You know, when things are hidden away behind paywalls or in hard to access places, then it's only the sort of super scientists that can get hold of it. But this way, it allows anybody to find our data and see what it says. And of course, more and more, because it's good citizenship, it's becoming expected by funders, especially public funders, like the NRF, or like when the NRF joins with the funders from other countries. The principle is public money means public outcomes. And then, of course, there's strategy. It's not just good science and good citizenship, it's also a good strategy for research data management, and it is certainly part of our strategy in CEBA. So for your academic career, this is important. It's becoming the academic norm. Most journals, when you send your article to them, want to know where the data is, or will be. It will become part of future career assessments. If you don't have data sets published, people will want to know, where is your data? And then, very selfishly, it gives citations for data as well as the publication linked to the data. So all round, it's good for your academic career. It's good for the CEBA footprint. It's not only good for individuals, it's good for CEBA as a research group. It showcases our research. It shows that that we have valuable data to share. And it replaces and extends appendices which would otherwise be hidden at the back of publications. And overall, it increases our credibility. So CEBA has its own portal on the UCT Ziva Hub. You can drill down, you can open CEBA and get our landing page and all our data that we've published to date. So what are the concepts behind creating data sets? What is the reasoning that goes behind it? What are the things that we need to have in our minds as we come to create data sets? The first thing is the principles that have been developed by the academic community who are pushing for academics to be open so that everybody can access them. And they've developed this acronym FAIR. Our data should be findable. People must be able to find it. And it must be accessible. People must be able to open it up. Mustn't be hidden behind a paywall. And it must be interoperable. People must be able to actually open it up and do stuff with it. And then it must be reusable and reproducible. People must be able to take our data and put it together with other data and use it, or take it and demonstrate something that we hadn't thought of. And they must be able to reproduce it. They must be able to take our data and do the same thing and get the same answer. And then our data has three facets, and we'll go into these a little bit here. The first one is what I call information data. This is my data, what we think of our actual data, you know, the numbers or the answers. And this is data that's been produced and collected by you yourself, but only the data that's directly related to the publication to which you are linking your data set. And here are sort of watchwords from that FAIR, from the FAIR principles, that it must be accessible and interoperable. So we try to make the form of our data something that other people can access and can use. And then the second type of data is something called metadata. Metadata is data about data. And the first kind is explanation data. If we think of information data as my data, then the explanation data is how I got my data. It's the data needed to understand and use the actual data. This is where we want to make sure that our data is reusable and reproducible by giving enough information about it. And then thirdly, there's location data. It's no good having all this stuff there if nobody can find it. So this is metadata type 2, if you like. It's data about where to find my data. It's the data needed to discover it and to open it up and use it. So these three facets we will be dealing with in videos number 3, 4, and 5 in this series. So here they are, my data, how I got my data, and where you can find my data. And we need to make sure that we've got all three of these things in mind as we produce our data sets. Then, of course, we often think of data only as numbers, but there are many different forms of data, and they all go into data sets of different types. But first of all, a little background. Data sets linked to publications are not giving what's in the publication again, they're giving the background to it. So for example, in the diagram here, we've got a graph which is in the publication, but there's background data. We may have the numbers in a table, we may have a diagram as to how this plant, for example, works. We may have definitions of the different elements that have gone into the graph. And then we may also have supplementary material, not material that's not related to the publication, but a few extras like extra graphs or observations that don't fit into the article but are important background to it, and maybe comparisons with other sets of numbers or other graphs. So the data set has got those two elements in it, the background data that doesn't fit in the publication, and supplementary data that doesn't fit in the publication. But then there are types of data. First of all, text. This comes in many forms, and often it will be in a table or in straightforward writing or lists, depending on what we're showcasing. And then there are numerical data, for example, often in tables, and then also, of course, graphs and charts are a form of numerical data. And then we do a lot of simulation in CIBA, and the code that we use for that is also data, and we want to put our code in our data set so that other people can run it. It's ready to run, and they can check, yes, it works. I also get those answers, and they can use it and alter it and transform it, but always, of course, giving kudos to whoever uploaded it in the first place. And then there's images. Images form a very important part of scientific data. All the graphs and charts, and photographs and diagrams, things like our experimental setup, microscope images and so on, all giving information. So as we do our data set, we've got all these ideas, forms in our minds, and we come to getting ourselves ready to create the data set in the next video. Just an acknowledgement that I've learned a lot from UCT eResearch and the Digital Library Services, and they're always there to help you as well.